back to Quick Concepts. Today we're going to be talking about diagonals of rectangular solids. This is kind of a harder concept just because you have to visualize things. At least I'm not good at that. So what am I talking about here? So you can have problems in your book like from lesson 5, number 19. It says find the length of diagonal AC in the rectangular solid shown. So the first thing I'm going to do is I'm going to draw this rectangular solid. Now bear with me here. Again, I'm not the best at this. So here's our rectangular solid. That one's ugly. Let me erase that and fix that one. We have an N here, a B here, an A here, 3, a C, and a 2. Okay, so what they want, it wants the length of AC. So if you try to visualize it here, I'm going to draw it. So if we were to do a diagonal from A to C, that's what it wants, okay? But the first thing we have to do is essentially look at the bottom of just this box. So I'm going to just draw the bottom of this rectangle. If I were to just draw the bottom of the rectangle, it would look like 3 and 2, okay? Now I want you to think about this. I'm going to draw the bottom of that triangle that it's making. Technically, that's a triangle, right? I'm showing you this part. This is the bottom of that triangle. So the first thing I'm going to do is figure out what that is. And I'm going to do that by using the Pythagorean theorem. So if we have a 3 and a 2, I'm going to say 2 squared plus 3 squared. And we're going to just call this BC. Because as you can see, it's B to C. Is equal to BC squared. So this becomes 4 plus 9 is equal to BC squared. This is 13 is equal to BC squared. And then if we take the square root of both sides, I can tell you that BC is equal to the square root of 13. Now I want you to think about it. That's the bottom of the triangle that we make with this diagonal. So now I'm going to draw that diagonal. Let me draw this purple. So the square I'm drawing, or I guess the rectangle, or the triangle I'm drawing now would be this one right here, here, and there. So if I were to draw that triangle, this is BC, this is AC, this is what we're looking for, right? This is N, and now we know that this bottom part is radical 13. So now it's just Pythagorean theorem again. So it's N squared plus radical 13 squared is equal to AC squared. So N squared plus 13 is equal to AC squared. And then if we're looking for AC, so we want to, I guess just adding those together, there's not much you can do here. If we take the square root of both sides, we can see that AC is equal to the square root of N squared plus 13. So as you can see, it's a little bit complicated. You have to kind of picture what's happening. So let's do one more of these just to make sure you have it solidified in your mind. Let's see if I can find one. This is problem set 7, number 22. And I'm going to draw it in red. So we have the front of the box here. And we have the back of the box here. So this goes to there. This goes to there. This, I'm going to make it dotted. Should have made that one dotted too. This goes to there. Okay, so we have 2, we have A, M, 4, B, C. So what it wants is it wants us again to find AC. So I'm going to take this and draw what they want. They want that diagonal. So the first thing we want to do is take the bottom of the box and just draw the bottom of the box just like it is. So this is M, this is 4. So the first thing I'm going to do is I'm going to figure out what this portion is. So this is B and this is A. No, this part is A. So what I would like to do is figure out that portion right there. What is AB? What is this? Because eventually I'm going to make this triangle here, and that will allow us to get AC. So we're going to use the Pythagorean theorem just like we did last time. M squared plus 4 squared is equal to AB squared. This is going to be M squared plus 16 is equal to AB squared. Taking the square root of both, I can see that AB is equal to M squared plus 16. So this is M squared plus 16, the square root of it. Now I'm going to extract this triangle. Now just so you know, this is going to be C here and B here. This is A. This part right here is AB, which is M squared plus 16. The height is 2. And I'm looking for this right here, which is my AC. So I'm going to use the Pythagorean theorem. So this will be 4 plus, this is actually going to cancel out that radical. And then we can say M squared plus 20 equals AC squared. And then I just take the square root of both. And I can see that AC is equal to the square root of M squared plus 20. And that is the diagonals of rectangular solids.